we can start on time, which is rare. Usually we start on at 5:05. We are live. Just give me a minute. I'll share it with our previous speakers, so you will have people watching you on live as well. And I'm also sharing the live link with you so that you can share in your group. It's in the WhatsApp group. I'm going to put it also in the LinkedIn and before we start. Okay, Keshav is joining. We just got free from the class, so as expected. If there is any message for you both, it will be in our group, just in case, if required. Okay?
Yeah, definitely.
So just for managing. Okay, before we start, may I request all of you participants and speakers are of course on video, just to please open your video, even if it is for 1 second or 2 seconds. It is just to check and make sure that we do not have any bot and everyone is human here, and to protect the session. It's for our betterment, so please bear with it. And this is something which we have to do for every session. So I hope you understand it. Then you are free to decide whether you want to keep your video on or not active. Usually we admire if you keep your video on, but it's up to you because of your internet connection. Because speakers feel good when they see people, on the upper back. But it's up to you. For me, the checking is done. So thank you so much for your understanding. Yeah. So we have Keshav. Are you settled? Do you have your glass of water? You want to breathe? You have breathing time because both speakers will present. So may I check your video, Keshav? Yeah. Yes. Thank you so much. Yeah. Take your time. Breathe and get a sip of water. So, Sunil and Somil, shall we start?
Yeah, we can
Yeah.
start.
Okay. Warm greetings. Welcome to another session of Wednesdays for Water. As you know, we recently crossed our 200 mark and we are really in a celebration mode because we are also booked until mid of October. So this has been a journey, 5 years. And we are so grateful to all our past speakers and our speakers for today, which I'm going to talk about in a short while. But I thought it is important to announce this, that today is our 201 session of Wednesdays for Water. So really very proud of the entire team also of W4W Foundation. W4W Foundation is a think tank initiated as Citizens Collective. Here we welcome you to another session of Wednesdays for Water. And today's session, we discuss flood risk intelligence and climate resilience solutions for urban watershed systems. Before we get into the session, a brief overview of Wednesdays for Water. The idea of the sessions are to engage in conversation with water experts, grassroots practitioners, policymakers, and youth to explore the complex intertwined issues associated with water and the possible solutions the speakers have been working upon and seeking for. With the success of Wednesdays for Water, we actually expanded to Friday Waters, which has 5 kinds of sessions: thesis club, reading club, water arts, water talkies, and meet a maestro. And we recently closed our Monday munching and musing with women for water after completing 100 sessions. All three of these sessions put together, we are now 450 sessions old in 5 years, making us the longest water conversation ever taken place anywhere. All this water knowledge is open access for all of you to enjoy, celebrate, and also be concerned about water. We have a new home now. Earlier, we were at www.w4w.in. Now we are at www.w4w.org in pursuit to slowly turning it into a new kind of institution by itself, which is run by all of us, for all of us, and it is for everyone. So today's session, it's really something very important discussion because half of the country is right now reeling under floods. And we know that climate resilience is no more a distant situation. It is there in everyone's life now. So we have two esteemed speakers today, Dr. Sunil Kumar Joshi and Dr. Saumil Swarnakar. They will make a presentation and we have a youth discussant, Keshav Tiwari. Before I invite to all three of you, thank you so much for agreeing to do this session and also in a very short notice because usually we are booking our speakers 6 to 8 weeks in advance. So big thanks to you for trusting us. Before we get into the presentation, a brief biography of each of the speakers and I'll do as per their presentation. So we start with Dr. Sunil Kumar Joshi, who is a water resources and hydrogeology expert with over 15 years of international experience in hydrology, hydrogeology, groundwater modeling, remote sensing and GIS, climate resilience, and water stewardship. I will keep the biography short here and put it in the chat box, but important to know that he holds a PhD from IIT Kanpur and is currently the founder and CEO of Hydro Canopy Analyst Private Limited. And he's also an ArcGIS expert with Carbon Check India Private Limited and AWS professional credential specialist. As I said, I'll put rest of the biography in the chat box and then I invite Sunil to please make the presentation. Thank you so much, Sunil, and also for organizing this event because you are kind of the, I will say, foundation for this session. Over to you.
Yeah. Thank you, Mansi. I'll just share my screen. Just
Sure.
please confirm if it is visible to everyone. So, can you see the screen?
Now, yes, please go ahead. Yeah.
So here, as you rightly mentioned, so we are two, first one I will speak and then my colleague Dr. Swarnakar will speak. So we have categorized into the part 1 and part 2. So part 1 I will lead and then I will hand over to Dr. Swarnakar. So the topic we choose here for the flood risk integration, intelligence and climate resilience solution. So the main reason to choose this topic because now we are in a monsoon season and we heard in a newspaper, in the television, like there is a flooding. Like Gurugram, there is a flooding. Mumbai, there is a flooding. Bangalore is also flooded. So those kind of news we are seeing if you're just talking about the national point of view. And the flood is also recurring. Like it is not like the one-time flooding in a particular area. It is like recurring at this moment. So we need to understand why the flooding is happening in every year in most of the region, and what is the triggering impact and the cause for the flooding. So that we need to understand. And the second thing we have mentioned like climate resilience and solution. So for this, we'll just use the climate parameters. What kind of climate parameters need to be used whenever we talk about the flood risk. So if I just talk about any cities like Gurugram or maybe the Bangalore, so they are habitual. They have adopted the flooding as a part of their life during the monsoon season. So I'll just go into one by one. Yeah. So second, in a first session, I'll just cover the theoretical hydrological point. So in theoretical hydrological point, we will talk about the infiltration factors, like what is the main cause for the runoff and the flood. So that is the soil infiltration factors that we will discuss. We will also discuss about their mechanism and also the runoff coefficient, because runoff coefficient will change places to places. Suppose if there is a concrete area, so the coefficient will be higher, and you can see the entire water will be moved from the particular area. And if it is natural surface, so there will be infiltration. The water will go as a subsurface, and it will recharge to the groundwater, and some amount of water will flow as a part of the runoff, and some will go to the atmosphere. So here, first, the theoretical physics that we need to understand. So we need to understand about the soil moisture. So the soil moisture, if you are talking, so what kind of soil type is available in a particular area? So the soil data set is already available from the FAO and from the NBSS Nagpur. So we need to collect the soil data set in a particular area. We need to check the infiltration factors or the infiltration rate in a particular region, so that there the soil moisture will help. And the infiltration rate, like how the water is infiltrated from the surface to the subsurface. So those things we need to understand whenever we talk about the theoretical physics. And the third one, but it is the main, the hydraulic gradient. Suppose if we are talking about the hilly area or maybe the flat topography, so hilly area like the Himalayan terrain, we can consider. So we will face like the whatever the rainfall or the precipitation occur, the entire precipitation will flow towards the downstream side, and because of the high hydraulic gradient and the slopey area. Second, if we talk about the plain topography, the Indo-Gangetic plain, so there is slope is very less, so we can see the water is moving, but it is spreading. So high area will be the water spread area in a particular region. So those things we need to understand. And the third one is like, the fourth one is like rainfall intensity. So as we know the climate change, so because of the climate change, the rainfall intensity is increasing. But there is an interesting point, like the rainfall pattern. If you compare the last 100-year rainfall dataset from 1901 to till today, till 2026. So 126-year dataset we have, if we talk about the Indian scenario. So IMD is having the dataset. So if you just compare the historical dataset, and you see the maximum annual total runoff will be different. But if you go with the projected dataset like the climate dataset, so the annual total might be less, but the one-day peak or maybe the few-hour peak will be higher. So that is the main reason we are seeing the flash flooding in maximum area. Like the huge amount of rainfall or the precipitation occur in very short time. So the watershed or the catchment will not have the space to infiltrate the water. So entire water or the maximum water will flow towards the downstream side. So those things we need to understand. That is the main reason we have covered the theoretical physics. And the next one is like hydraulic variables. So in hydraulic variables, we need to understand the conductivity, like hydraulic properties of the soil and subsoil. So like surface topography is not a one aspect. We need to consider the subsurface aspect as well, because the infiltration and the other factors, how it will recharge to the groundwater, those things should be considered whenever we talk about the flood. So here you just see the rainfall infiltration related aspect. So if you see the first top image, so there is a natural topography in a 3 dimension. The blue color you can see is the water, and the green color is like a vegetation or the green cover area. And here you can see the streams. So these streams are coming from upstream or the hilly area, and it is going towards the ocean. So the flow direction is from left to right, if we talk about the watershed. And here are some kind of activities are going on there. And for this area, some plantation and some industries are there. And here you can see some tube wells. And this dotted line you can see, so this dotted line is just like a water level below the surface. So if we just see the natural topography, so we can see the first image. But if we trying to model these things, like how we can project, how we can understand the historical pattern, how we can understand the projected pattern, then we need to understand their property based on the modeling approach. So here you can see the 3D. So this is nothing. This is just a replication of the particular top image in a down. But you can see the different grids. So these are the grid as per the resolution. So initially we have a like Landsat imagery, but now we have a Landsat, we have Sentinel data. we have a list4 data, we have a Cartosat data. So the resolution is increasing. Like you have a high resolution data at this moment, but initially we have a less resolution data set that we are using for the modeling approach. So if we just go with the modeling, so we need to provide each and everything as a part of the grid. And then you need to include the subsurface aspect. And then you can add the river profile, like you can see the straight line. So this is the stream in the model. But actual stream looks like this one. And in the model, it will looks like this one. So if you have a high resolution data, then it will provide the more realistic picture in a particular model. So these are the just understanding how we can think about the rainfall or the runoff infiltration things in the model. And these are some factors or the parameters that need to be considered while going to the modeling. And the main factors are just like a precipitation. So the rainfall will be the main factors, and evapotranspiration is also the second factor that need to be considered whenever we talk about the runoff. And this is the column, like surface column or the subsurface column. So you can see different kind of unsaturated and the saturated zone. Here you can see the blue color dotted line. So this is nothing. This is just a water table. So water table is below the surface. So above the water table, there will be unsaturated zone, and below the water table, that will be the saturated zone as per the hydrogeological terminology. So those things need to be understood before working on a flood related aspect. Yeah. So the another aspect is like the coefficient, like runoff coefficient. So here you can see the 0.9. So it will be up to 1. 1 will be the maximum. So if the higher runoff coefficient, that means the entire water will move from upstream to downstream. There will be no recharge. And whatever the precipitation occur, it will go towards the downstream side. So now the maximum area, urban area in a particular city. So the runoff factor is continuously increasing. That means we are disturbing the natural topography while constructing the infrastructure. So that is the main reason for increasing of the runoff factor and also the flooding. So the things are like the porosity, soil porosity, and the soil saturation. So these are another factor that we need to consider whenever we talk about the porous media. So these are the part of the subsurface, because if we are just talking about the natural undisturbed land maintenance valence ratio of the micro and micropores. Like suppose if the natural topography is there you can see the green cover. So the water will infiltrate in a particular area. But if you put the cemented area, then the entire water will flow and it will go towards the slopy area, slopy region. So those things need to be considered whenever we talk about the pore space distribution and also the impervious barrier. So in impervious barrier, we can clearly say about the entire area will be the cemented in a particular region. So this kind of scenario we are seeing into the particular city levels. Okay, so the next and the main point we need to understand about the river meandering and the floodplain in a particular region. So if you see the left image, so left image, that is just a 3D of a particular river, and the river is coming from north and it is going towards the south. So you can see the terminology like depositional and the erosion. So if the river will flow, so this area will be eroded, and the entire sand particles or the soil particles, whatever is eroded from here, it will deposit it at this location. So the flow will come from north and it will go towards the south. So this area will be eroded, and again you can see the meandering. So this area will also erode in a particular region. So after some time, it will be looks like this one, and this picture will change. So the initial day one, you can see the depositional and the river pattern like this, but in after a couple of years, you can see this kind of pattern. So this pattern can be seen in maximum alluvium river, or if you go to the Ganga river system, so similar kind of pattern you can see in India. And how it will impact to the subsurface or the the particular cross section of the region. So if we just see this bottom image, so this bottom image that indicate the erosion, deposition, and also the cross section. So here yellow color that indicate the sediment that is deposited, and for this area you can see the more erodibility, and there is a bank erosion we can consider. So here in the right side we are just displaying only the example. So this image is for 1965 that we use from the USGS. So and you can see the January image and also the March image. So within 3 months, what is the scenario? So first A image, you can see the land particles here, and the river is at this location. But after a couple of months, that is within 2 months, the entire area is eroded, and the built up region, you can see this building like 30% or the 40% is on the air. So we need to understand how the river is behaving in a particular area. So these are the critical points that need to be understood before talking about the flood and any other aspect regarding the flooding and the climate change. So the second part will cover the climate forcing and the hydrogeological aspect and the hydrological aspect. So here I'll just give the brief about the moisture scale, because suppose if the soil is there, if the moisture content is there, then definitely it will be good for the soil health, and also it will be good for the particular infiltration and also the evapotranspiration. So now we'll just talk about the spatio-temporal flood extremes. So this is the image in the right side you can see. So this is just an extreme event. So in any area in the globe, if there is a peak rainfall will come, the city will be like flooded. So the main reason for the flooding is we do not have a proper stormwater connectivity. Suppose if we have a stormwater connectivity, so we are not properly managing or the maintaining the stormwater. So that is the main reason we are facing the flooding into the roads and also the low-lying area in a particular city. Here, this is just information about the IDF curve. So IDF curve is a main that we need to understand before going with the flood-related aspect. And then I'll jump to the part 3, that is a regional case study. So I'll just give few case study that is only for the India. So I'll cover the Mumbai, Chennai, Bangalore, Delhi, and also the Gurugram. So if you just think about the Mumbai, Mumbai located into the coastal area, so the flooding will cause due to two factors. First factor is due to the flow from the upstream to the downstream, and the second, the high tide impact in the coastal region. So suppose there is a flooding in a particular watershed, and the water is coming from upstream and it is going to the sea, but there is a high tide impact. So the water should not go into the sea, and the entire area will be flooded in a maximum area. So you can face the similar kind of things in a Mumbai region. So that will impact two things. Like the first one is tidal impact and the flooding occur due to the tidal impact, and the second one is due to the river system. The next case study is for the Chennai. So Chennai is also having the flooding because of the low-lying area. And initially there was a spongy wetland we can say. So the area has been reduced as per the original size as per the literature. So the main reason is encroachment to reduce the particular wetland area. So we need to understand, we don't want to encroach the particular water body area so that the area will be flooded. So we need to think how we can avoid those kind of issues so that flood will not be there in a particular region. And the next one is the Bangalore. So Bangalore is also flooded because of the cascade channel system and also the catchment hardening. So catchment hardening is a part of the urbanization, and cascading system, like you will have a multiple channels or multiple small water bodies located in a particular area. So that is part of the cascade channel system. And there is another flood event in a Yamuna. So Yamuna in a Delhi, we are hearing multiple times because Delhi is flooded because of the Yamuna. So the reason, like the maximum places in the Yamuna, like that is on an active floodplain where we can see the flooding continuously. So left side and the right side of the Yamuna River, wherever we found the active floodplain, you can see the flooding. And Gurugram is also one of the area where we can see the flooding. At this moment, there is continuous infrastructure projects are going on. So Gurugram is a low-lying area if we consider, and there is a major hill like Aravali hill is there. So whatever the runoff is in the Aravali hill, it will go towards the Gurugram region as per the watershed. So it will flow towards the downstream region, and the area will be flooded. So those things need to be considered before going with any kind of infrastructure project in a particular area. And also another thing is there is no natural infiltration capacity because of the urbanization in a particular region. So these are some case study that we need to we are hearing every time. Even though this year we have seen multiple news regarding the flooding in this region. So how we can resolve this kind of issue? So this is the critical question. So at this moment, we have a very advanced technology. We are using the remote sensing dataset. We are using the SAR dataset. We are using the AI and ML approach. We are going with the IoT sensors. So those things we are using to resolve the problems. So first we will talk about the SAR. So SAR is like that is synthetic aperture radar. So it will provide the data set like this is the microwave data set, and it will give the realistic picture about the surface. But you need a actual like real-time data set if you are talking about the SAR data. The second one is like LiDAR data or maybe the satellite elevation data set that we need to understand. But at this moment, we have available data set is like only the SRTM elevation data. So these data set are helpful. But the data published during 1999 and 2000. So now we are in 2026. So we have a 26-year-old data if you are using the SRTM. So, but maximum people they are going with the SRTM dataset because it is freely available for any kind of modeling. So this dataset is available for the entire globe, so we can easily use. But you can see the vertical error. So there is 8.5 meter vertical error if we use the SRTM dataset in a particular city planning. So we need to go with the real-time data or maybe the year whenever we are starting the construction. So same year or maybe the 1 year before the dataset is required while doing the assessment. Second one is the CARTO-DM. So CARTO-DM is an Indian satellite data set that can be used. So they're giving different kind of labels. So some data set are freely available, and some high resolution data set you need to procure from there. And the LiDAR data set. So LiDAR data, you can fly the drone and you can get the data set. So you can see the accuracy, like 0.1 meter will be the accuracy. That is vertical accuracy. So you will have a good amount of information if you're using the LiDAR data set for your analysis. So this is also the real-time hydroinformatics architecture. So first one is the radar-based data set that can be used. And we need to think about the IoT level sensors. So if you're just talking about the early warning system, so we can put some kind of IoT-based sensor in upstream area, and we can monitor into the downstream region. And we can also think about the predictive AI because AI is growing. So we need to utilize the AI for in all our models so that we will have a good outcomes. And here, the fifth part, I will just give only 2 or 3 examples, and then I'll hand over this session to Dr. Sonkar. So Spongy City, like this is a big and very old concept, but this will help to reduce the flooding. So I'll just give one very good example. Suppose if the spongy cities are there, so you can see the dark green color. So the infiltration factor will be higher in a particular region. So if the infiltration will be higher, so there will be higher chances for the recharge. So the groundwater will recharge and the water table will come up. So you will not face the groundwater declining problem in a particular region. Second one is like the spongy wetland. So if the wetlands are there, so wetland is good for the ecosystem and it is also good for the groundwater recharge. And the evapotranspiration will also there if and some controlled surface discharge. So the discharge will be controlled if you are going with the spongy city water allocation planning in any aspect. And here are some good pictures as per the nature-based solution. If you are talking, so first one is like how we can think about the biocells. So these biocells will provide the good good and the nature-based aspect if you're talking about the particular city. And we can also think about the bio retention cells. So that can be placed in a particular city. So it will recharge the water and it will also hold the water. And we can also think about the floodplain restoration in a particular area. So these are the critical points that need to be understood before going to the flood risk assessment. Yeah. So Mansi, over to you.
Thank you so much, Sunil, for this wonderful overview. I will invite Dr. Somil Swarnkar after a brief introduction of his career. Dr. Somil Swarnkar is an assistant professor in the Department of Earth and Environmental Sciences, IISER, Indian Institute of Science, Education and Research, Bhopal. He has obtained his PhD in Earth Sciences from IIT Kanpur and completed his National Postdoctoral Fellowship in the Interdisciplinary Center for Water Research, IISc Bangalore. His research focuses on hydrology, climate change, flood and drought extremes, sediment dynamics, river basin processes, hydroinformatics, remote sensing, and artificial intelligence application in water resources. He leads the Stochastic Hydrology Lab at IISER Bhopal, where his group is developing advanced statistical machine learning and process-based approach. I now invite you to make the presentation because we are so much looking forward to more and more solutions and the way forward. Over to you, Samir.
Thank you so much, Mansi ji, for nice introduction. Uh, and thank you so much, Joshi ji, for giving a very nice overview of flood and the development which we have seen so far from different fronts. For example, let's say remote sensing or machine learning or sponsity or sustainable development, etc. My talk would be focus on particularly the technical part of a flood. I will try to make it as simple as possible so that people can understand this. Suppose if you have, let's say, a decade of data set of, let's say, hydroclimatic variables, etc., how we can use those data set and then we can infer, okay, this is flood and this is non-flood, like that. So, yeah. Rishi, can you move to types of flood? So, the floods can be many types. Primarily, we can define into 6 different major types of flood. First is a riverine flood, which is caused by overflowing of the water, which is flowing through the river channels or minor tributaries, etc. Flash flood, where generally occurred in those areas which we have steep slope, and we have also have a very intense rainfall event. Cloud burst event can also be can trigger the flash flood events in the mountainous region. Coastal flooding is also one of the type of the flood, which is caused by storm surges, high tides, and wave from the ocean and sea, and then basically accompanied by those cyclone events. Then we have also a fourth type of event, which is now we are seeing very common problem across multiple urban centers. For example, pluvial flood, which is also called urban flood. So because we have a lot of constructions everywhere and there are limited space to the water can go penetrate inside the ground surface, and therefore we have a lot of water accumulate in those areas. That is basically called urban flooding area problem. So there we have higher intensity of rainfall, and that's basically stores at a very longer period of time, and that creates some other types of linked hazards. Then we have a dam break flood. So it is basically kind of a cascading event where we have a dam break, or you can also connect this with the GLOF event, glacial lake outburst flood. So basically where we have a natural water stored there at a lake or somewhere, and there are certain, boundary has been escaped, or basically because of that, we have a lot of water flows through downstream and creates flood. And then we have also groundwater flood, which is basically kind of, we can say, saturation driven flood. And sometimes this groundwater over, groundwater saturated soil column can also create, extra water in that surface, and remaining rainfall, which is happening at the same time, can create flooding events in those regions. So broadly, we can divide flood in these different categories, and based on this categorical understanding, we can basically understand the exact flood behavior of that particular region. Next slide, Rishi. So what is flood generation mechanism? Because let's say if you wanted to work on flood and wanted to develop some machine learning model or hydrological model, etc., we need to know about why a flood is actually occurring in a particular place. Is it because of climate change, or is it because of the climate driven, or is it because of some sort of human activity, or it is not a flood but people are living close to the river system, and that is basically some sort of a high flow flood can occur there, and therefore that is basically create a flood. So flood generation mechanism can be understood by rainfall characteristics. It can be high intensity rainfall and long duration and large spatial can cover, and that can create trigger the flood, related problems in that particular region. Antecedent moisture conditions is one of the important conditions. For example, let's say if you have a big storm, and before that, what is the ground's saturation level? Whether ground is fully saturated or not saturated at all. Saturation means what is the soil moisture, the percentage, or how much total column of the soil has been already saturated there. So if this is basically fully saturated, then which means whatever the rainfall we will receive, it will form some sort of surface runoff and it will create a flood there. And another kind of conditions can also be possible. Let's say we have a very high intensity rainfall and it can create very quickly saturate the upper layer only. And that basically can create some sort of flash flood or urban flood as well in those regions. Basin and topographic factors also one of the important players. For example, what is the basin size? If we have large size, it will have higher runoff productions capacity. Slope is one of the factor which determines the velocity of the flow. And the fourth factor is basically the land use and land cover. Of course, it is one of the another key factors. For example, what is the urbanization there, how much water can be there, or because of the urbanization or concrete surfaces. Deforestation is another issue, because let's say if you have forest area, flood water can be can have some sort of resistance because of the tree covers and all. But if you don't have forest there, there will be no resistance to the flood velocity, and it will create flash flood hazards more frequently. Then we have impervious surfaces, which is linked to the urbanization, etc. Then fifth is basically reservoir and river operations. Sometimes reservoir release or gate operations or flood routing system can also malfunction or can create some sort of a pseudo flooding situation in a certain regions. Let's say if it's a dam break conditions or overflowing of the reservoir in a certain region linked with at the same time a high extreme rainfall event. Then we have snow melt and glacial melt. If a large amount of glacial melt is stored there in a lake or some sort of surface water bodies, can create some sort of a flood also. And then most important factor is climate change. Climate change is actually increasing the extreme rainfall variability. We have frequency, we have higher intensity rainfall, and that can trigger multiple types of floods at the same time and can narrow the recovery window at a given locations like that. So overall, flood generation mechanism can be understood by taken into account all these different factors together, and then we will be able to understand exactly what is the cause behind one particular type of flood. Here in this the right side of the cartoon diagram, we are also listing different types of flooding possibilities or how they are basically interacting with different topographies, etc. Here in the right side, if you look at a kind of a conceptual flood hydrograph where we have shown some sort of rising limb and the recession limb. It is a kind of when we have a flood event, how data of river discharge actually behaves. And by knowing these factors, we will be able to connect these to the physical process, for example, rainfall or soil moisture or urbanization, etc. Next slide, please. So now we can closely look into that part, the discharge and time, the flow flood hydrograph part. We can see here there is a event which start to rise, and then we have basically there is a flood peak, and then there is after some times it basically return to the normal conditions. So during this whole rising limb, it is basically called the flood amplification period, and it reaches to the peak value. And after that, achieving to that peak value, it basically again goes back to the normal conditions, which is called the reduction of the flood magnitude over the time windows like that. So the rising limb of a flood hydrograph are always determined by the climate variables because what is the type of rainfall, how extreme is the rainfall. So it is actually defined by the climate factors, how hydroclimate actually forcing towards to floods to occur in a particular region. But on the other hand, if you look at the rising limbs of a hydrograph, it is basically driven by catchment characteristics. For example, what is the total area of the catchment? If it is a large catchment, it will have a larger recession limb, because it has a large areas of storages there, possibility of storages there. So slowly they will release that water from that particular areas like that. Or it is also possible that it will driven by the slope, or it will driven by the land use, land cover characteristics, or it will driven by the soil type, or it will driven by the geology, for example. So these are the basin characteristics which defines the rising limbs. Why it is important to understand? Because when we know that the rising or the recession limb, we will be able to make some sort of better forecasting model, or go with the better management strategies in that particular regions as well. So flood characteristics, if you wanted to study, that is a very a good. Have to understand about what is flood peak, what is flood volume. Volume can be defined by just integrating this particular graph, the hydrograph graph, and then what is the total duration of the flood in one particular region. Then we can also look at the rising limb, we can look at the recession limb, and then we can also look at what is the overall a return period. So when we are mixing together all these different properties, we can comment on whether a flood which occurred in a particular place is a flash flood or flashy event, or it is a kind of a moderate flood which is having a moderate intensity but large durations like that, or it is kind of a prolonged flood because has a very long period of time. It is taking recession limb, and but has a accumulating a lot of volume in during that particular period of time. So this is basically the very important key characteristics when we are mathematically understanding the process behind the floods and using the flood hydrographs like that. Next slide, Lucy. Yeah. Now, the one of the major important analysis of flood is called flood frequency analysis. Why it is important? Because we always look at, let's say, if some floods are happening at a particular region, what is the return period of this flood, which means how many years it will take to return back to that same magnitude level in that particular locations like that. Why it is important? Because let's say we are planning to build some reservoirs, we are planning to build some dams, we are planning to build some urban areas, we are planning to build some sort of river corridors or river, river multiple types of structures in river around. So for that purpose, we need to know about the flood frequencies. Sometimes, most of the times, we also use these flood frequencies for identifications of those regions which are highly flood prone. For example, we know that if we have 10 that flood which is coming every 10 years will basically submerge very close areas of the river channel. The flood which is occurring, let's say 1 in 100 years, it will span a larger area, but it will not be very frequent. So these kind of understanding, if you wanted to develop, we have to go through some sort of a flood frequency models. Basically, it is driven by two different types of time series of data. One is called annual maximum series, and the other is called the peak over threshold method. Annual maximum series are driven by generalized extreme value distribution models, and peak over threshold is basically driven can be calculated by the general Pareto distribution. So this is called a statistical ways of how we can determine, let's say, if we have given one station data and we wanted to know that what is the 100-year return period magnitude with some uncertainty, and let's say if we know that okay, Q is equal to 4000 Qmax, what is the return period of this particular flood in that particular location. So all of these questions can be answered through the statistical framework, through the mathematical modeling, and we will be able to answer those questions from the data set. Next slide, Lucy. The other part of the flood modeling is also called flood hazard modeling, where we are looking at whatever the regions which are going to be inundated because of higher floods, or let's say if you know that the flood magnitude is some value x value, and it is basically return period is 50 years. It comes every 50 years like that. So for that particular flood, how many area is actually going to be inundated if that flood will occur there. So that kind of understanding we can develop using inundation modeling or some sort of hydroclimatic data set. We integrate this data set into the hydrological modeling. Then we do some sort of hydraulic modeling, and then we do GIS processing, and then mapping the flood areas like that. Using this information, one can also be able to understand where the settlements can be located, housing and other things, or critical structures can be placed. Because if we know that this area is flooded every 10 years, which means the flood is very common in those areas, that should be a red flag. We should not build any construction in those areas like that. So flood zonation, flood mapping is very important when we know all these different aspects of this. So we can use this concept in spatial distributions, and we can do a lot of multiple, develop insights using for practical purposes, etc. This is the next slide. Yeah. So there are several flood data sets are available. For example, we have rainfall data, which are provided by IMD in India Meteorological Department. ERA5 is a reanalysis data set, which is also provided. CHIPS data is also available. These are the free data set. One can just go through their website and download this data set and start processing the data, etc. Streamflow data is also for not confidential river system. Confidential means those transboundary river systems which are sharing borders with neighboring countries like Bangladesh and Pakistan, etc. So the peninsular part, let's say Narmada and Godavari, Krishna, and all other river basins, we have the data set freely available. One can directly download the data set from India Varis and CWC. They request the dataset from CWC from also, and then they can start processing the data and doing that analysis. We have a USGS Streamflow global dataset, GRDC, that is also available. There are digital elevation model, which is also covered by Joshi ji. They have shown that their accuracies, for example, SRTM and LIDAR and other dataset type. So we have LOS Pulsar, we have Copernicus DM, and other DMs are also available. We have different types of land use land cover data set. For example, we have ESA word cover, MODIS data. We have Sentinel-2 derived land use land cover data set also available. We have different soil data set also available. For example, soil grids, FAO soil, and there are several NBSS, which is basically the Indian agency, which also provides a soil cover data for entire India like that. Satellite data, we can use Sentinel-1, Sentinel-2. Sentinel-1 is a kind of a active remote sensing data where the radar, the data set is basically based on active remote sensing, which means that data set is not being distracted by or have any interaction with the high flood conditions. We also have a lot of information during that particular time. Sentinel-1. Sentinel-2 is a kind of optical data. We have to rely upon the source sun. So therefore, there is a cloud cover interactions can be possible, and that has to be removed. So Sentinel-2 is available, which is very high resolution data set, around 10 meter, 20 meter. Landsat data is 30 meter, and then we have MODIS data, then we have GPM, emerge data, and other data set can also be utilized for this flood mapping or flood modeling. We have flood inventory also available. For example, we have GRDC. We have different types of, India Flood Atlas. We have Dartmouth Flood Observatory dataset also available. So these are benchmark, can be become benchmark dataset where we can use our analysis, and we can use their data set, and we can match them so that we can understand whether these two data sets are giving the correct results or not. And we have further ancillary data set. For example, we have roads, we have buildings, we have reservoirs. These are safe files. They are location specific data set also available, can be utilized for vulnerability assessment or risk mapping, etc. Can be used for that. Next slide, Sushit. So this is the last slide. I would like to highlight here the emerging research direction in the flood science. We are looking at, let's say, compound hazard, because flood can be coupled together in multiple hazards like landslide, maybe extreme rainfall event, or could be a glacier linked flood event. So there are compound flooding events can be possible, and that we need to move in that direction, not to treat flood event as a isolated event. We have to make together multiple types of hazards together, and to analyze their better insights. Flood synchronicity and connectivity is another area is now growing in India, where people are not talking about one location specific flood, but they are looking at, let's say, 100 stations. We have data, and they are trying to look at what is the chances of all hundreds are going to be flooded at once, or let's say out of 150 stations are going to be flooded in once, like that. What is the probability of that? Is there this kind of pattern occurred in the past duration or not? That people are trying to understand. Human influence and regulation impacts, that is one of the very critical areas. So how human activities are actually amplifying or not amplifying the flood behavior in a particular region, that is actually one of the very growing areas, and people are working on those particular areas like that. Advanced observations and remote sensing, people now these days we have a lot of UAVs or smaller satellites, or multiple advanced satellites are also there. So can we use those advanced data set to better predict the flood behavior in the future or current situations, like that? AI and machine learning, of course, because we have a lot of non-linearity in the system, and of course hydrological model, or any model which is based on physical governing equations has some limitations, because we cannot understand the whole natural process correctly. Therefore, AI model and machine learning model can give us the non-linearity component, which cannot be explained by the mathematical terms, that these models can easily learn. Then we have climate change and non-stationarity. So this is basically one of the also very important area, because people thinks usually floods and other things, climate extremes, are stationary in time. Stationary means it is not changing in time, it is just stationary behavior. But over the time, the behavior has also been changed, their distributions has also been changed. So can we understand their non-stationarity behavior linked to the climate change and other best practice methods, so that we can have a accurate information of floods? Then we have flood propagation and early warning. Can we do something, predict a flood week before, or few days before, so that we can better plan management strategies in those areas? There people are also working, developing IoT sensors, and using the remote sensing data set, high UAV surveys, etc. So people are taking a lot of technical advancement and doing in that area. Nature-based solution, which is also covered by the Joshi ji, and for example, Sponge City and other type of nature-based solutions, how we can incorporate in flood management studies, like that. Then we have digital twin concept, where we are making a digital twin of the earth system or particular region, and then we start simulating different scenarios. Suppose if temperature is going to be increased, or rainfall are going to be increased in that particular region, what could be the potential impact on that particular region in terms of flooding hazards? So that can also be used for emerging future research. And then we also have to develop some sort of social dimension, risk governance together. We have to keep the vulnerability assessment, hazard mapping, risk mapping together, so that we can have exact picture. Okay, so these are areas are marginalized community are living there, their vulnerability is very high. So whatever, if the flood will occur, we have to go there, and we have to provide the relief and other things first, like that. So this kind of the framework we should have, so that we can minimize the the casualty and impact caused by the floods, etc. So with this, I would like to conclude my talk, and if any questions, we would be happy to answer.
Thank you so much, Somil. And may I request to close the PowerPoint presentation, please? Yeah. Thanks, both of you, for the wonderful and elaborate presentation. To be honest, it's like also a masterclass for all the youth here. I can already see that so many PhDs can pop up, and no other than our discussion today to be encouraged to take this up as a PhD. So we have Keshav Tiwari as our discussant today. Keshav Tiwari is a master student at the Indian Institute of Forest Management, Bhopal. So you are very close to Somil, as you can see, Keshav. But other than that, Keshav is also our junior research fellow at W4W Foundation, and I would definitely vouch for all of you to watch his YouTube space, where he is also making some very interesting graphics on the ThoughtPad. Keshav, you heard both our speakers, and over to you. And this is also a time I would also like all participants to please join this conversation. You can put your digital hand up and Keshav will invite you on board, or you may also write your question in the chat box. Both options are there. While you start working on it, Keshav, I will check from YouTube if there are any questions or comments. Over to you, Keshav. Keshav,
Keshav, you're not audible.
yeah, you are not audible. Let me just see. Do you have a microphone or something so you can get rid of it? That maybe that. Can you hear us? Yeah, you hear us, but we don't hear you. Okay, while Keshav is setting up his audio, let me just ask my question, because I usually ask my question at the end, but everyone here is also encouraged to do that. Please put up your questions. So we saw some really overwhelming, I will say, knowledge repository available on flood science, from early warning to looking at the social governance. So I will still like to ask this question, probably it's an urge. How far our local authorities are equipped to understand this knowledge? And if they are not, what kind of steps are being taken forward? And if they are, why do we still have flood?
Yeah, so I'll take this up. So previously, I was a part of the one capital city that was going to establish in South India. I will not mention the name of the city. So we have seen the flood report. We have gone with the flood risk assessment as well. So those kind of quality check I have done. So I have clearly mentioned approximately 35 to 40% city will be flooded every year, whenever the peak flow will come. But due to the political interest, the city is going to develop. So this is the main factor that we need to understand. So that will kill the entire ecosystem in a particular in an active floodplain. So first we need to understand this one, and the second, we are encroaching to the river. Like suppose if any open channel are there, so we are establishing one shop or maybe just half portion of a particular house we are adding in the river system. So this will also kill the natural flow of the river system. Like you have a like river is having their river space, but we are occupying that due to the encroachment. So this will be the another factor. So these are the key things that is still need to be understand, and we need to educate the local. So there should be multiple training program with the local people. We need to educate the local authorities with the proper examples. So then it will be resolved.
Today's session was really good, huh? With examples. So that's really nice.
Yeah.
Let me check if Keshav is back, because actually he should get the privilege to ask the questions. Keshav, can we hear you now? Yes, we hear you. Go ahead, please. Yeah.
So thank you for this opportunity, ma'am, and respected professor. It was a very good talk for me. And uh, regarding floods and type of floods, I was having full picture. But when AI came into the presentation, I had few doubts. So the biggest doubt which I have from this entire hour was the challenge in predicting the floods. As we as the sir has mentioned, that there are various reasons why a flood happens. And like how will you address the challenge? Multiple uh, multiple hazards and multiple things with happening. So how will you build a prediction model on that? Uh,
So who
especially
wants to take
considering
this
the
question?
So there is a lag in the voice. So
So,
The question is also in the
I'll
chat
type the
box.
question here.
Yeah. Somil, do you want to go for it?
yeah. So,
Yeah, go ahead,
what is
please.
the biggest challenge in the developing accurate flood prediction model? This is the question, the first question. Yeah. So the biggest challenge currently is the data.
Hmm.
Data is gold for hydrologist. If you don't have data, we cannot do anything. So, for example, uh, we need to, for accurate flood predictions, we need to develop a very high resolution monitoring stations across those critical areas at least. For example, we have multiple flood events which happen in Uttarakhand, Kedarnath, Joshimath, and Uttarkasi and all those events. So for, let's say, if those events have been already occurred, we need to develop very high, resolutions network so that we can have a very good amount of data and we can use that data set for modeling. The other thing is basically uh, biggest challenge is basically the, of course, understanding. For example, there are several events happened. We need to develop what is the process behind each. Then we will be able to find out. Yes, machine learning AI can help us, but up to certain limit. If we do not have the physical understanding, then we will not be able to solve that problem. Yeah, we can use it as a data science, but physical understanding is very important. And when we incorporate those things with physical in this, the machine learning tool, I think we will get more better insight. So that is, I think, Joshiji may also add something here.
yeah, so you're right, Dr. Soumya. So the thing is like data is the critical point at this moment. And if you are going with the high resolution data, then you need to go to the field, you need to collect the data. Then it will be the very good model. Like suppose if I am saying about the drone data, so you can see the centimeter or the millimeter accuracy. If you fly the drone, you collect the data. But that is a very costly. Suppose if I'm going for the 1 hectare drone survey, so the cost will be the major factor. So, but if you go with the low resolution data set, it is freely available. Some data set is also we can procure, but there is also the coarser resolution. So the limitation of the high resolution data is the primary cause that we need to understand. Yeah.
So it's like flood crisis is data crisis, the way Niti Aayog calls as water crisis is data crisis. Over to you, Keshav. Please unmute yourself. Yeah.
It's a data crisis, yes.
Yes.
Uh, in the last slide, you also mentioned about the compound uh, hazard, which model, I think.
Mhm.
So, yes, sir. Now, moving on to the second question. So, sir, how do you get the historical data? Right now, establishing infrastructure is going to be a problem. So, can we use historical intensity duration to data for predict for building the prediction model? I had this.
Yeah. So you are asking about intensity, duration, frequency curve, right?
Yes, sir.
Historical. Okay. So the problem with historical IDF curve is, I think, we are assuming a stationarity in IDF.
Mm.
Stationarity means we are assuming that nothing is changing. Suppose we have, let's say, 30 years or 40 years record at a one particular location, and we have developed IDF curve. And assumption is that the hydroclimate is not going to be changed; it will remain same like that. But that is not happening. So climate is changing, and therefore the property of rainfall, runoff, everything will also change. So I think that is where, if we assume this is a fixed thing, maybe we will have some uncertainty in our result. we need to upgrade our modeling setup with some changing parameter or non-stationary conditions. Then we will accurately predict the flood behavior or other extreme events behavior like that.
Keshav, unmute yourself, please. Yeah.
Yes, sir. And sir, as it was discussed in the previous discussion that uh, establishing monitoring systems is going to be a cumbersome and long-term process. So my third question would be like, so why cannot we use satellites or synthetic aperture radar to get a more real-time data? It would be far quicker and cheap solution. So what do you think about this?
Yeah, so your question is valid question, Kesa. So like SAR dataset is reliable, we can use. At this moment, we have a Sentinel dataset. So from there, we are using the optical dataset and the micro dataset. But the frequency is every 10 or 11 day interval. So you will not have a daily dataset if you are just talking about these satellite data. And also the SAR data, like the frequency is like sometime it is in the month, sometime it will be in a year. This is the main factors for the non-real-time monitoring using the SAR. So you need to capture the data set for the particular reason, and you need to develop the different IoT system. Like suppose if you are in a water set, so in upstream region, you can just put some IoT sensor and it will measure the water level, how the water level is coming up and down in a particular river. And it will directly link with the master control room. So from there, you can go with the like warning system. Like suppose in upstream, there is a precipitation and the water level rise in a particular stream. So you will get the alarm as per the early warning system in a master control room, and the master control room people they can just go with the siren or maybe they can go with the SMS related aspect. So the downstream community will be aware. Okay, the flooding will occur in a particular region. So those kind of scenario need to be considered whenever we talk about the real-time flood prediction and the monitoring. So last year we have done some work with the this Himachal region. So we did only the the assessment. We have not installed any kind of IoT based sensor for the monitoring, but the real time assessment we have done. We have prepared the EWS like early warning system for them for a smaller catchment only.
Nice. Keshav, unmute yourself if you have question. And I want to ask you a question, Keshav. How do you see an opportunity for you to take up your PhD? Because I was so, impressed by the way last slide, Somil, you presented with the options of flood science. And I'm always looking for the way water is being taught across the country. And yes, I said he's one of the leading institutions to teach these ways. What do you think, Keshav, from forest to water? I think his network got stuck, but maybe while he comes back, we can invite Dr. Sazina Bhimani because she has a question. So, Sazina, would you like to unmute yourself and ask? And other participants, you are also requested to raise your digital hand or ask your question through chat box. And we have Sunil and Samil for a few more minutes. And meanwhile, Sazina, I can see your question, but I don't see you anymore right now in the network. But you have been with me telling your network issue. But maybe Sunil and Somil, you can check this because this is something getting very, very crucial in urban areas. And she talks about during flood. Sewerage
Yeah.
also gets overflow and that leads to shallow groundwater contamination. What's your experience on this? And I mean, I'm curious because it's a little bit of different question than what you made presentation. But when you talk about data integration, are you able to factor this aspect also into it? Because it's now a
Yes.
very common thing. We all live it. Go ahead.
Yeah, so this is very good question, and all the urban city, whoever is facing this kind of flooding issue, they are facing the contamination into the groundwater. So the main reason, like suppose the sewerage water is there, and it will be directed to the storm network, so it will infiltrate into the subsurface and it will contaminate the groundwater. That is point number one. Point number two, during the flooding event, if there is no proper maintenance of the storm network, so the entire area will be like blocked and the water will be stagnant. So you can see water accumulated area in a particular location, and it will evaporate and it will also recharge as a part of the infiltration. So that will also contaminate to the groundwater. So these two are the critical aspect that we need to understand. But there is a contamination into the shallow groundwater, and if we are going with the proper maintenance, so we can reduce the contamination. We cannot say we can go with 100% reduction of the contamination, but some portion we can reduce, because now there is a multiple approach we are using, like ETP, STP we are installing, so that the waste particle will not go into the storm. Yeah.
Nice. Keshav, do you have any other question? Because I think your network went out when I asked you a question about how do you think linking your forest masters to now the next step to PhD? You are not far from ICER, but it was very nice to see how Somil presented the options. But I'm sure there are many youth in the audience today who would also like to explore these possibilities. We need many more water scholars in this country. And here is a palette of options which Somil presented. What do you think, Keshav?
Yes, ma'am. It's definitely a golden opportunity for you, and I will make sure I will full use of it. Ma'am, as far as questions are concerned, I had one last question regarding runoff
Please go ahead.
coefficient. What understand this thing, how it is affecting prediction. Runoff coefficient. If you can please elaborate.
Okay.
Who wants to answer it?
So Dr. Sorka, you are speaking, or shall I? Yeah.
तो ये बताइए जी.
Huh?
Yeah, please go ahead.
Okay, so the problem is like runoff coefficient. Suppose that is the maximum value you can get one. So that will be like entire, if the entire area is cemented. So whatever the precipitation will come, so it will precipitate on the surface and it will flow as per the natural topography. So if the cemented particles are there, then the 100% amount will be flow. There will not be a chance for the recharge. And if the natural topography, like the natural grasses are there and the forest area is there, then the some portion will go as a part of the infiltration. So that will there will be runoff coefficient will be less. So these are the two criteria. If your runoff coefficient is higher, you will see more runoff. If your runoff coefficient is less, you will see less runoff.
Yeah. Wonderful. Actually, I am now pressed to ask a question. Probably you both can decide who wants to answer it based on this. On one hand, we are urbanizing in leaps and bounds. On the other hand, we are losing our wetlands. Classic example, Sunil, you also talked about the vanishing wetlands of Chennai, one of the key reasons. And I can say from my own work on urban lakes for over 30 years now, that one of the key reasons of having this urban flooding, which is not a natural process, is because of the loss of the lakes. Do you see many of these direct evidences that we can relate through studies that these many loss of lakes in terms of area and volume of the water bodies is kind of directly interlinked to the amount of flooding in the city? I mean, I'm just curious because then I will be very keen to find a student who can work on this, and I'm very happy to support that student who would like to link flood and lakes. What's your take on this?
Yeah, so I'll start, then Dr. Sonakar will contribute. So the first point, like we are disturbing the watershed. So why we are disturbing? Because we are just making some infrastructure like road and river, road and other infrastructure we are developing, and we are not giving the proper space to channelize the water. So now, if you see maximum metro cities, we have disturbed a lot, and there is no proper flood modeling for the particular area, because if the higher amount of runoff will pass from one location. So we need to design the culvert, like how it will pass from the this road network or the this railway network. So those information we are not putting because we are not more focusing on the flood risk assessment. That is first. Second, there is a the flood area, like the flood inundation area we are talking. So based on the flood risk, you will have a flood inundation area. So those aspects we are also not covering. If we are covering, then there will be proper channelization or the proper flow into the downstream region. That is second. And the third one for the urban, the major problem is encroachment. So we have seen in many locations, and like some of the location in Gurugram, that is the pond area, historical time, and now there is no pond, there is no signature of the water body. So I have done one case study for the Gurugram area during the month of May, and we use a historical data set like last 15-year data set we have used as a satellite, and we have also used this topographic seed that is for the 86. So in 86 there was a water body, but now there is no water body. So that is because of the urbanization and the encroachment. So we need to think how we can channelize the flow without disturbing the natural topography and the water set.
On the same line, I would like to just give a very short story. I lived in Bangalore, so there a place called Mathikere. I think Kere is lake in
Yes, Kerry is lake. Yeah.
lake. So there no lake. There was no lake. So it was
Yes.
Mathikere. There was no lake around. So I was surprised where is lake. So Bangalore used to be a lake city where a lot of lakes were there. But now we have urban flooding problem because all the lakes were like simply covered with mud, and then builders have made buildings and all that. And because we don't have a proper, so drainage will go in that direction. So if huge amount of
You
rainfall
can't hide topography.
cannot be,
Yes.
yes. So it will always follow the slope. So so the that is a very classical example. Even many other cities like
Many
Hyderabad is following
cities.
the same footstep, and other cities like that.
Delhi,
That is
Delhi, led by capital of the country, Delhi itself.
Delhi itself, yes. Yeah. So last year, Yamuna flood occurred in
Yes.
that bridge. Yamuna was very close to that bridge, and people are saying now it is a flood. And now, when we look at the past record, it seems like it is actually the natural channel of that
Yes,
Yamuna.
absolutely. Absolutely. Yeah.
So
So go
I
ahead.
think
Go
we
ahead,
need to
Samir.
change our. I think we need to change our definition of flood. I think.
Absolutely. And I think we also need to use science more in our policy and development of the society, which is still a weak link. And as scientists and as practitioners like you both, you have a major role to play how to convince politicians and policymakers to really incorporate this rich information and data already available. I would like to close here the session today because we are already overboard. And Keshav actually is also our video editor of the session, so he knows what he has to do. But let me tell you, a lake lost is a land gained, and that is how urbanization has happened. My city, Ahmedabad, when I did masters like Keshav, 630 lakes. When I did my PhD after 20 years, 122 lakes, and 1 hour of rain, and you have at least from ankle to knee depth of water near my house. So we have actually created the flood, and now there are scientists and people who have created the flood science. Now it's about who is going to bring them together and make a marriage out of it. But thank you so much, Sunil, Somil, and Keshav for this wonderful session. Can't ask more from such kind of session. What a master class it was. Before I let all of you go, I would like to announce the next session is equally interesting. But this time coming from the ground, we have on July 22nd, Wednesdays for Water on Kerala Waters, Voices from the Ground, and we hear what youth and what local people talk about Kerala Waters. You know that it is again going through problems. We will continue our water conversation as long as we can, and it is only possible with the support of speakers like today. And when they suggest us more speakers, we have been going as a snowball sampling. And we have touched so many lives. We really want to continue this. And personally, me, Mansi, I really enjoy being student for some time. Thanks all of you. Please take care of yourself. See you soon. Bye bye.
Yeah,
Thank you,
thank you. Yeah.
Bye bye.
Bye bye.